Hi ladies, in this video we're going to go through your revision test. So 25 questions, fast forward if you need to, rewind if you need to, pause if you need to, do whatever you need to do. Okay, let's get started. So question 1, complete the expansion by collecting like terms. So remember, like terms have the same pronumeral part. So for this question we've got, and I'm just going to look at the pronumeral part, not the coefficient. So we've got a y squared, we've got a y, and we've got a constant. So effectively we've got three different types of terms. We've got a y squared, we've got the y's, and then we've got a constant. So when we're collecting like terms, we're only collecting our y's. So we've got -8 minus 21. So our answer is -29. So all I need to do is write in 29 as the answer. Okay, let's move on. I'm using a new program here to draw on PDF, so I'm hoping that it works and get through to question 25 without any problems. All right, question 2. So we've got a binomial here, x plus 2 times x minus 6, and we need to expand that. So when we're expanding, we do our first for each bracket, so our first terms, and then our outside terms, then our inside, and then our last. So we've got x times x, which is x squared, x times -6, so -6x, 2 times x, which is 2x, and then 2 times -6 is -12. Now, just like before, we've got our like terms here and here, so we've got to add them together. So I've got x squared, -6x plus 2x is -4x, and then we've got -12 on the end. So the correct answer, let's just find it, it's a bit hard to read, isn't it? Okay, is answer C. So x squared minus 4x minus 12. All right, question 3, the missing term in the factor is. So we're looking for this question mark, the number that's represented by this question mark. Now remember, when you're expanding, we do our first two terms first. So basically we've got some number, which is represented by that question mark, times 6k is equal to this first part, 24k squared. So you can use algebra if you like, and we'll just divide both sides by 6k. So we're left now with just our question mark, and in algebra usually we use the letter x to represent an unknown. In this question it's just got a red question mark, so it's kind of like the same thing. All right, so we've got 24 divided by 6 gives you 4, and then k squared divided by k gives you 4k. So your answer there is, and I can't really fit it into the box, but I can write next to it, is 4k. All right, moving on to question 4. Which of the following statements is true concerning the expanded forms of x plus 7 times x minus 2 and x minus 7 times x plus 2? All right, so the two products are the same. This just means when we multiply them, they're the same. So products means what you get when you multiply. The expanded forms differ only in their constant term. The expanded forms differ only in their x term, so what their coefficient of x is, and the expanded forms differ only in the x squared term. Now I know what the answer is, okay, but if you probably the best way to do it is to actually do the multiplication. So this first one I'll just go over here because we don't have much room on this page. We're going to have x squared, then we've got minus 2x plus 7x, so it's going to be plus 5x minus 14. And then for our second one we've got, and it's a bit horrible that it goes over the line, but we're smart here, we can actually see that we've got an x plus 2. So x times x is x squared, x times 2, and then minus 7x, so we've got minus 5x, and then we've got -7 times 2 is minus 14. So you can see that this middle term is different, okay, but your x squareds are the same and your constant terms the same. So your answer is, the expanded forms differ only in their x term. Okay, so your answer for that one is C. All right, question 5. All right, so what this question requires you to do is just expand, and then we've got to write what A, B, and C is. So A being the coefficient of y squared, B being the coefficient of y, and C being your constant term. So when we're expanding, remember we do the first terms, the outside terms, the inside terms, and then the last terms. So 4 times 2y is 8y. Then 4 times 5 is 20. Negative 3y times 2y is negative 6y squared. And then negative 3y times 5 is minus 15y. Okay, and I'm just making sure that's all good. Now we just have to rearrange so we get it in this form. Okay, so at the moment it isn't. So we're going to put our y squared term first. So we've got negative 6y squared. And if it helps, you can cross out the term as you go along, but I'm not going to do that because I'm keeping these solutions here for later. Then we add our like terms. So we've got 8y minus 15y, so we've got minus 7y. And then we've got 20, so plus 20. So in my spot here, A is negative 6. Okay, so just the coefficient of y squared. Coefficient of y is negative 7. And then C, your constant, is 20. All right, so we'll scroll up. Question 6. Okay, so again, we need to, this is a bit hard to see, a bit of a horrible question, but there is, now let me just think, what is it wanting us to do? Oh, okay. Okay, so when we simplify this, okay, we are going to get a coefficient of x. Okay, so basically you've got 2 brackets and we've got x plus 5. Sometimes they're a bit hard to understand what the questions are asking, but there's a coefficient of x, and the easiest way to work that out would be just to say, well, if I multiplied these 2 terms, and remember I said there's a coefficient of x there that we need to work out, so that has to equal 4x squared. Okay, so we've got a coefficient of x, and we're going to square that, and we get 4x squared. So basically, what number do we need to square to get the 4? And that is 2. So your coefficient here is going to be 2. The good thing about quadratics is you can always check your answer. So I'm just going to put the 2 in there now. So you can say 2x times 2x gives me 4x squared. 2x times 5 is 10x. Then we've got another 10x. So that gives us the 20x. And then the 5 times 5 gives us 25. So you can always go through and check your answer. All right, question 7. What is the highest common factor for the terms in 4p squared 12 minus 12p minus 16? Okay, so first of all, look at the first term, okay, because you want a factor of the first term and every other term. So I've got a coefficient of 4, so I can say, well, does 4 go into 4p squared? Yes, it does. Does 4 go into minus 12? Yes, it does. And into minus 16? Yes, it does. So you're going to have a 4. And then let's look at the p squared. So this has both p or a p squared, but you can see we've got a p here, but no p on the constant term. So your highest common factor is 4. Now I'll just explain why they've done that. Is because you would then take 4 out as a common factor and you've left with p squared minus 3p minus 4. And then you would factorize what we've got in the bracket. So that's why it's asking what the highest common factor is there. All right, question 8, complete this perfect square. So when we look at the coefficients of this first term, so remember, this is going to be expanded from two brackets. So the 9n squared would come from your 3n times 3n, and then your last term comes from these two numbers. So what's going to give you 25 is 5 and 5. Now, because they're both plus, we can add them. Okay, so basically your perfect square is 3n plus 5 squared. But we need to work out what this coefficient of n is. So we're just going to expand the brackets. So as I said before, the 9n squared comes from this first term, 3n times 3n gives you 9n squared. This last term comes from multiplying your 5 and your 5. But what we haven't done is 3n times 5 and 5 times 3n. So 3n times 5 gives you 15n. And then 5 times 3n gives you also 15n. So we've got 30n. So your middle term here is 30. And you can, I'm just trying to think. Yeah, you can expand the whole thing if you like to work out that you also get 9n squared and 25. But it's doing the multiplication of your outside terms and your inside terms that gives you that coefficient of n. All right, question 9, complete the factorization. Sorry, I just had to pause that so I could think about it a bit more. Now, we're going to do factorizing by grouping. So this one here, even though it's using the letters, which is sometimes a little bit hard for people to understand, we've got to say, all right, if I just look at this green section, what is a factor that is common to both AB and 3A? So I can take A out as a common factor, and I'm left with B plus 3. So I put that in brackets. And then this blue section, okay, I've grouped these two terms. I've got 2b plus 6. So the highest common factor of 2b and 6 is 2. So I'm going to do plus 2. And then I'm left with b plus 3. So remember, when you're factorizing by grouping, the whole purpose of it is to get brackets the same. Okay, so you can see you've got b plus 3. So that is one factor. Okay, so a factor that is common to both a, b plus 3 and 2, b plus 3 is b plus 3. And then what are you left with? You're left with a plus 2. So in your space here, you should have b plus 3 and a plus 2. All right, question 10. Simplify this fraction. Okay, so I got it, difference of perfect squares up the top, and then I know that's going to cancel out with what's on the bottom. So questions like this are usually designed so you can do a bit of cancelling. Remember when you do the difference of perfect squares, I'm going to write that up here, y4 minus 16. Okay, we've got this, we're going to identify a and b. So a is just the square root of this first term, which is y4, which is going to be y2. And then b is the square root of your second term, which is square root of 16, which is 4. So when you're doing difference of perfect squares, we just then add a and b. So y squared plus 4. And then we subtract a and b. Oops, why did I write b? I always do that. What's my rubber? Cool. Let's rub that out. And text her back. Okay, y minus 4. Now, if you're ever unsure, you can just expand that. All right, and still haven't finished. I just realized. Okay, so we've got here now y squared plus 4. We can't factorize that anymore, but you can actually factorize the y squared minus 4. So this question here is probably quite a tricky one. So I'm just going to rewrite the y squared minus 4 here. I just realized we haven't quite finished the question. And I'm going to use another color. So this is difference of perfect squares again. So a, different a, is the square root of y squared, which is y, and then b is the square root of 4, which is 2. Now, I knew I had to keep going because firstly, I should have read the question properly, but I needed to cancel out with this y plus 2, and I haven't got y plus 2 yet, so I knew I had to keep going. All right, so y squared minus 4 then becomes a plus b, so y plus 2, y minus 2. So girls, this really requires you to have an understanding of the difference of perfect squares. All right, I'm going to use a different color again. Let's use purple. So to bring everything together. So remember, I couldn't factorize y squared plus 4, so I'm going to keep that here. I can factorize y squared minus 4, so I'm going to write that. And I'm probably going to write over this green. So let's just try to squeeze it in. And then as the question says, we've got y plus 2. So I'm going to have y plus 2 on the bottom. I'm going to put that in brackets because I like when we're dealing with multiple terms to put them in brackets. All right, so these cancel each other out. And then I'm just left with y squared plus 4 and then y minus 2. Okay, so y squared plus 4. Might not write that in purple actually because it's a bit hard to see. So might stick back to the red. Just get the red up. Okay, so y squared plus 4, y minus 2. So quite a tricky question there. And girls, there are some tricky ones on here, but your test, so I've chosen questions for this revision from levels 1 to 4, 4 being the hardest, and this is a level 4 question, but your test will be made up mostly of level 2 type questions, okay? So when you think of level 1 being the easiest and level 4 being the hardest, your test will be at level 2. Okay, question 11. All right, so we've got n squared minus 12n plus 20, and we've got to work out what the missing sign is. Okay, so even if you have to guess, you've got a 50-50 chance of getting this right. But let's have a look at what we've got here. So if you think about this 20, that has, and it's a positive 20, has come from multiplying this together. So if we did positive 10 times negative 2, we're going to have negative 20. So this must be a minus sign. And you can also see here that it has to be a minus sign. So B has to be a negative. It's probably good there's not much working out there because I didn't have much space left. All right, question 12, enter the missing number. So I've got m squared minus coefficient of m minus 20. So similar to before, you can expand. So m times m gives you the m squared. Then we've got m times 10, negative 10. So I'm going to write that down. And then 2 times m. And then we've got 2 times negative 10, which is where that negative 20 comes from. So we only have to deal with this coefficient of m. So negative 8m plus 2m gives you negative 8m. And the question already has a negative there. So just be careful with that you do take that into consideration. So we only need to put the 8 in, not the negative 8. All right, question 13, factorize k squared minus 13k plus 40. So we need two numbers when multiplied give us 40 and when added give us 13. Now the good thing is they've already given us one of those numbers. So, and in this space, we should have k, and it's already got the minus 5, so I'm going to put the minus 5 in. And then it's going to be k something. So what two numbers when multiplied give you 40? So what do we need to multiply negative 5 by to get to 40? So you can say negative 5 times what gives us positive 40. So two negatives have to give you a positive. So I know it's going to be a negative number. So what do I multiply 5 by to get to 40? 8. So you're going to have k minus 8. And if you wanted to double check, remember when you add the two numbers together, you should get negative 13. So negative 5 minus 8 gives you negative 13. So I know I'm correct. So in this spot, you should have k. And in this spot, we should have k minus 8. All right, moving along. Question 14. Use the information in the equation to complete both the expanded and the factored form. All right, so I know, remember, it's a bit hard to see when you've got those blank spots, but we've got P plus something. Now, these two outside numbers have to give us 32. So what do I need to multiply 8 by to get that 32? And the number is 4. And then that'll allow me to get this coefficient of P. So remember, P comes from multiplying this P times 4, so 4P, and then your 8 and your P, so plus 8P. So that gives you 12P. So here we need to have the number 12. Okay, and if you needed to, you can expand the whole thing. But effectively, you're just looking for two numbers when multiplied gives you 32, and when added gives you 12. So those numbers are 8 times 4 gives you 32, and when we add them, 8 plus 4 gives you 12. All right, so understanding how to factorize monic binomials. All right, question 15. Factorize n squared plus 8n plus 16. All right, so what we need here is, I might just pause for a sec. Sorry, girls, I just had my son, you probably couldn't hear him, but calling out from downstairs. Okay, so we need two numbers when multiplied give us 16 and when added give us 8. And you can kind of see as a hint here that that number is going to be the same because we're going to be squaring it. But your two numbers, when you're factorizing, you're thinking of factor pairs. So you can have 16 and 1, 2 and 8, 4 and 4. Okay, but we need whatever those two numbers are to add to 8. So in this case, it's going to be 4 and 4. Okay, so 4 times 4 gives you 16, 4 plus 4 gives you 8. So because they're the same, you're going to be having 4 plus 4, sorry, n plus 4, n plus 4, which is the same because the brackets are the same. It's this, keep saying the word same. It's the same as squaring them. So we've got n plus 4 all squared. All right, question 16. Which of these is a factor of 6y plus 14? So a bit of an easy one here. So what number goes both into 6y and 14? Well, 3 goes into 6, but it doesn't go into 14. So it can't be 3. Y goes into 6y, but it doesn't go into 14. 2 goes into 6y and also 14. So C, 2 goes into, so the number 2 goes into both 6y and 14 and therefore is a factor. All right, question 17. Which of the following shows the factors of 11k squared minus 46k plus 8? So here we're moving into non-monic binomials. So that just means we've got a coefficient of k squared that isn't 1. Now to factorize these, and I've only had one student so far tell me you can use the quadratic formula, and that's very true. You can use the quadratic formula for any quadratic, but we're going to not use the quadratic formula here. We're going to use what the how you've been taught in the textbook, but when we get to solving, okay, so that's the second part of chapter 5, you'll be introduced to the quadratic formula. All right, so basically the first thing we do is identify A, B, and C. So A being your coefficient of k squared, B being your coefficient of k, and C being your constant. Now, when we're factorizing non-monic trinomials, we need to work out A times C first of all, which is 11 times 8, which is 88. And then we need to work out, all right, I had to just pause again, sorry. So two numbers, sorry, let's start again. So multiplying A times C is 88, and we need basically two numbers that give you 88 but add to negative 46. So we need now two numbers when multiplied give you 88 and when added give you the coefficient of k, which is negative 46. Now, you can think it does take a while sometimes, especially when you're working with these larger numbers, to find two numbers when multiplied give you 88. So obviously you're not going to use 11 and 8. Okay, they're going to be different factors. So I'm going to think of, because we've got a negative here and a positive here, they're going to have to be two negative numbers. Okay, because we've got a positive here, A times C, but a negative here. So to get this positive, they both have to be negative numbers. All right, so two numbers when added, I got 44 and 2. So negative 44 times negative 2 is negative 88, and minus 44 plus negative 2 gives you negative 46. So when we're factorizing a non-monic, we keep our first term the same, so 11k squared. And then we just use these two numbers. So instead of writing minus 46k, I'm basically just splitting that negative 46 into 2. So negative 44k minus 2k. Okay, so it's still equal to negative 46. I've just split it up to allow me to factorize. And then we've got plus 8 on the end. And then we factorize by grouping. So I say, well, what is the factor of, actually I might use two different colors here. So we're going to be grouping. We're going to look at this first part. We'll call that the green part. And then this second is the purple. All right, so 11 and 44, the common factor is 11, and then k squared and k, we've got k. So we're just factorizing this green section. And then I'm left with k minus 4. All right, and then we'll factorize this purple section. So I've got plus and 2 and 8 go into there. So I'm going to leave plus 2. And then you can see I'm going to have a minus k, whereas I had a positive k here. Now this is where you need to say, well, if that's going to be the case, let's change this to a minus. Let me rub it out and change, whoops, didn't mean to delete all that. Oh, go away. There we go. All right, so I'm going to say my common factor is negative 2. And then I've got k minus 4. Okay, so I got what I wanted. So if I kept this as a positive 2, I would have negative k plus 4 in my brackets. But remember, the whole purpose of grouping is to have one bracket the same, or your two brackets the same, so k minus 4. So we're taking k minus 4 out as a common factor, and we're left with 11k minus 2. All right, and if I look at my answers, you can see this second bracket is first, so I'm just going to rewrite it. It doesn't matter because we're multiplying them. Okay, so these two things are equal. I've just switched the order of the brackets. So we want 11k minus 2, and then k minus 4. Just thought I put a mistake there. K minus 4. So just make sure I'm good, and B is your answer. Now, if you wanted to check, you can just quickly expand. So 11k times k is 11k squared. 11k minus 4, negative 44k, minus 2k minus 46k, and then negative 2 times negative 4 gives you 8. So let's say all this, that was very difficult for you, and you came across a question like this. There's nothing stopping you from working backwards and actually expanding your answers to get the factorized form. It might take you a while, especially if your answer was D, but it's one way of doing it. Or you can say, well, I know that the last two numbers in the brackets have to add to positive 8, so you can go through and do maybe a process of elimination. So if you did that, it wouldn't be C and it wouldn't be D. So then you're decreasing the number of choices to 2. Okay, so there are other ways you can do it if you find this way of factorizing quite difficult. But remember, you can always check your answer, which is good. All right, question 18. Which of these is a factor of 3 times n plus 4 plus 5n, n plus 4. Okay, so again, this is by grouping. So I'm going to just underline. So we've got this part here and our green. Okay, so I can see already that n plus 4 is a factor. Now, if we look at 3, 3 is a factor of this first part, but not the second part or the green part. 5n is a factor of this second part, but not the first. So your answer is C, n plus 4 is only common to both the purple and the green section. All right, question 19, factorize. So similar to what we did here. The good thing is they're given us part of the question, which might help. All right, so I'm just going to separate this so we can do the question. Now, identify your A, B, and C. So here's our A, here's our B, and our C. So the first part is doing A times C. So 12 times 6 is 72. And then we need two numbers when multiplied gives you 72, and when added gives you the coefficient of P, which is 17. So the good thing is it's jumped right out at me, and it's 8 and 9. Okay, so 8 and 9, 8 and 9. So 8 times 9 is 72. Awesome. 8 plus 9 is 17. So when we're now going on to factorize, we keep the first term, 12p. Actually, do you know what I'm going to do? I'm going to do that a little bit higher, just so I can write on the page. All right, so we keep the 12p squared. Okay, so the purpose of factorizing or doing this is to rewrite the 17p. So we're going to write it as plus 8p plus 9p. And then what are we left with? 6, so plus 6. And then we can do the factorizing by grouping. So we're going to have this purple section and this green section. All right, so what is common to both 12p and 8p? It's 4p. So we take that out as a common factor, and I'm left with 3p plus 2. And then the next one, I'll take out 3 as a common factor, and we're left with 3p plus 2. So remember, the aim is to get the same bracket. If you don't, you've probably made a mistake somewhere along the line. So we take 3p plus 2 out as a common factor, and we're left with just 4p plus 3. Okay, so in this question, let's just have a look. Make sure we're writing it in the same order. So I need to rearrange it to 4p plus 3. So just putting brackets around the other way. Okay, what I've written first is not wrong. Okay, but because we're going to be entering these into Cambridge, we do want to put them in the right spot. So 4p plus 3. So you can see the plus 3 there. And then 3p, so the coefficient of p, plus 2. Okay, so just writing your answer there. All right, question 20. The area of a rectangle is given by the expression 2x squared plus 11x minus 40. The width of the rectangle is x plus 8. What is its length? Okay, so if you want to, you can draw it. So we've got x plus 8 here. Now, the thing is, it is requiring you to actually factorize this. So this is a hard question. So we're going to do a times c first. So 2 times negative 40 is negative 80. And then we want two numbers when multiplied give us negative 80, and when added give us positive 11. Now, I know one of the numbers is going to have to be positive and one is going to have to be negative. So maybe we'll just make this first number a negative, and I'm just going to pause so I can think of what they might be. All right, so your two numbers are going to be 16 and 5. Okay, so 16 times 5 gives you 80, and 16 minus 5 gives you 11. So that just gives you a hint as to which one has to be the negative. So negative 5 plus 16 gives you positive 11. Okay, so it's very important that you do take care with which one is negative and which one is positive. Okay, so we've got 16 and -5. So I'm just going to factorize this. So we've got 2x squared, and we're going to just rewrite this. So plus 16. Oops, what am I doing? Yes, 16x minus 5x. It's funny, when I'm doing questions like this, I think of other things. I think ahead when I should be focusing on what I'm doing. All right, so let's factorize by grouping. So we've got that part, and then we've got this section here. All right, so what number is common in this purple section? So we've got 2 is common to both 2 and 16, and then x is common to x squared and x. So we're going to have 2x, and we're going to have x plus 8. And then in this next section, now I can already see, because this is positive, that this number that I'm taking out as a common factor has to be negative. So taking -5 out as a common factor, and I'm left with x plus 8. So then I've got x plus 8 multiplied by 2x minus 5. So in this spot here, your length is going to be 2x minus 5. And you don't have to work out what x is because they haven't told us what the area is. If we knew what the area was, you could probably work it out what x is. Okay, so question 21. Which of these expressions is the expanded form of x minus 5 over 2 squared? So let me just get rid of this. Now, when we're squaring this, sorry, we're going to have, well, it's probably easier to expand it so you can see what is actually happening. So we've got x times x, which is x squared. Then we've got x times -5 squared, so minus 5 on 2x. Then -5 on 2x, so minus 5 on 2x. And then we've got 5 on 2 times 5 on 2, and because they're negatives, we're going to have a positive answer. So we're going to have 5 on 2 squared. So let's tidy things up a little bit. So we're x squared. This is 5 on 2 is the same as 2.5. So if it's easier for you to think of it as a decimal, so we've got -5 on 2 minus -5 on 2, which gives -10 on 2, which is the same as 5. And then 5 squared is 25, and then 2 squared is 4. Okay, so our correct answer is going to be B. All right, question 22. Select the equation below that cannot be factored using real numbers. Okay, so this is where you need to consider the difference, completing the square, and whether we can do the difference of perfect squares. So when we're completing the square, we've always got to consider the coefficient of x. So that's your b. Okay, so in this, we're going to go through each one separately because we need to know which one cannot be factored using real numbers. All right, so the coefficient of x is b. So then we do b over 2. So in this case, it's 18 over 2, and then we square it. So we're going to rewrite this expression. So let's look at a first. X squared plus 18x. And this is where the completing the squared comes in. We write plus 18 over 2. So I'm going to write just 9. And then there's a reason why we leave that in brackets, and I'll explain that in a second. Because we've added it, we then have to subtract it. So I'm going to leave it as 9 squared because you can then see, well, we haven't added anything because as soon as we've added something, we've taken it away. So effectively, we haven't added anything. We've just done something so we can complete the square. And then we've got minus 7. Now, it doesn't really matter what is happening in these first three terms, but I'm going to complete the square anyway. So this is the same as x plus 9 squared. Okay, so if I expanded that, I will get this. So obviously that's 81. The reason I left it as 9 is because that will always be that number there. All right, and then we've got negative 9 squared, which is negative 81, minus 7 gives you minus 88. Now, I don't need to go any further because I know I can factorize that by using the difference of perfect squares. So if there was a minus sign here, okay, it can be factorized. So this one cannot be. This one can be. So that's not our answer. So then we just have to keep working through them. All right, let's look at question B. So we do the same thing. So I'm just going to put a line under there. We've got x squared plus 18x. Okay, so I've got 18 over 2 here. So plus, similar to before, the only thing that is changing is this minus 100 at the end. Okay, so I'm still left with x plus 9 squared, and then negative 81 minus 100 is, got my bracket there, minus 181. Okay, so I can factorize B. Okay, so we can keep going, but you might see a pattern happening here. So let's just do C. So see how both the first two terms for each answer are the same. They're all x squared plus 18x. It's just this constant term that is changing. So effectively, we're only looking at this part here. Okay, so I'm going to just look at that part. So for C, we're going to still have minus 9 squared. Okay, that's going to be the same, but I'm just going to have that constant. The constant is changing. So plus 90. So negative 9 squared plus 90 gives you negative 81. Remember, that's in brackets. So it's not negative 9 times negative 9. It's 9 squared, and then you've got the negative there. So that's going to be negative 81 plus 90, which gives you 9. Now, because that is a positive, this is your answer. It cannot be factorized because when I put it back in with the x plus 9 squared, we're going to have plus 9, all right? And we can't factorize that using the difference of perfect squares because you have to have a minus there. So we can't factorize C. But let's just compare that to D. I might use a different color, go back to red. So again, remember the first two terms are the same. So we're only looking at this minus 81 part, which is the same for all of them. And then we're going to add the constant, so plus 30. And that's going to give us negative 51. So we've still got that minus there. Whereas in the previous question, you can see there in the purple that we don't. So when factorizing, we're going to have x plus 9 squared minus 51. And because of this minus sign, we can factorize it. So the only one that can't be factorized is C. All right, question 23. All right, we're nearly towards the end. Complete this equation. So we've got x squared plus 30x plus 7. All right, so we're just going to complete the square here. Let me just separate this. Really don't have much room. Okay, we don't have to go too far with the question anyway. So we'd identify B first of all. So B is equal to 30. So when I complete the square, your first two terms stay the same. And then we're adding 30 divided by 2, which is 15 squared. Then we subtract it. And then our last number is 7 plus 7. Okay, so we've got x squared plus 30x plus 15 squared. So that's going to simplify to x plus 15 all squared. And then I'm left with negative 15 squared plus 7. So 15 squared think is 225. Let me just double check on my calculator. Yes, so we've got minus 225 plus 7. So we've got minus 232. So a bit of a tricky one, but here we've got x plus 15 minus 232. All right, question 24. Now this is where we're going to be doing the difference of perfect squares. So you can see the minus there, which means we can factorize it. So your value of a is just the square root of this first term, which is x minus 1. And b is the square root of the second term, which is 2. So when we're doing the difference of perfect squares, we do a plus b. So there's our a plus b, which is 2. And then a again minus b. All right, and then we obviously can add these numbers together. So negative 1 plus 2 is x plus 1. And then x minus 1 minus 2 is x minus 3. Now, you can see here we've got the plus, so I'll put the 1 in here first, and x minus 3 in that second spot. All right, last question. Complete the factors for 4x squared minus 20x plus 18. All right, girls, I just had to delete what I had written. I had done this question, and when I checked my answer, my value of b was wrong, and I have no idea where I went wrong. So I'm going to attempt this question a different way to what I did before, even though you don't even know what way I did before. I actually took the 4 out as a common factor later. So instead, I'm going to take the 4 out as a common factor from the very beginning. So, and I'll explain in a sec why, but some of you might be sitting there thinking, why wouldn't we use a quadratic equation? And yes, you would, but it's still you need to know how to complete the square. At least do that, because when you complete the square, you're actually getting your expression in turning point form. And when we do parabolas, that'll probably make more sense. So completing the square, you do need to know how to do, but if you're just simply factorizing, you would obviously use the quadratic formula. And as I said for a previous question, we're going to be doing the quadratic formula or learning about the quadratic formula, but not until the second part of chapter 5. Okay, so let's move on. All right, so taking 4 out as a common factor will leave me with x squared minus 5x plus, now you're probably thinking 4 doesn't go into 18. No, it doesn't. So I'm just going to leave it as 18 on 4. Now you can rewrite that if you like, just to make it a little bit nicer. 18 on 4 is the same as 9 on 2. Okay, and then I'll just make things a little bit easier later on. Now I'll leave this 4 out the front, okay, and we're just going to complete the square with the expression inside the brackets. So we keep the first 2 the same. All right, we're going to add b, which is negative 5, on 2 squared, and then we're going to take it away. And then we add the 9 on 2. Okay, so similar to before, we are dealing with fractions, which sometimes can be a real pain in the bum, but the process is the same. So you just need to take your time. All right, so whatever is inside this bracket is what we're going to put here. Okay, so if I expand all this, I will get this. And then we've got, and I'm just going to put another bracket around here now because we're dealing with quite a few brackets. And then we've got minus negative 5 on 2 squared. So negative 5 squared is 25, and 2 squared is 4. And then we've got plus 9 on 2. And maybe I should have kept it as 18 on 4 before. Okay, it's a bit silly how I changed that. So all I'm doing is adding 18 on 4. I know I simplified it here, but I'm now realizing that I have to go back to 18 on 4 for me to be able to add these together. So they've got the same denominator. And then I'm just going to finish off that bracket. So the 4 stays there. We've got x minus 5 on 2 squared. Okay, so that stays. Then I've got negative 25 on 4 plus 18 on 4. So negative 24 plus 18 gives you negative 7. Okay, and now we've got, we can do difference of perfect squares. So I'm just going to scroll. Now, at this point, you can expand this 4 in. So I'm going to do that. So 4x, whoops, sorry, 4 times x minus 5 on 2 squared. And then when I multiply this 4 by the 7 on 4, that disappears. So I'm just left with that. And I'm just going to just do a sneaky look at my calculator just to make sure I'm on the right track. Okay, so now let's complete the square. So this part here is your A. Let you calculate your A. So A is just the square root of this purple section. So we're doing difference of perfect squares here. Don't forget your square sign. And then B is the square root of 7. Okay, so that's going to leave me, oh, it's going to write it in purple. Okay, so 2x minus 5 on 2. And B is going to be, oh, square root of 7. Okay, so we can't simplify that any further. Now remember your difference of perfect squares, once you've identified A and B, it's just A plus B, A minus B. So we've got A, which is 2x minus 5 on 2, and then we've got a plus root 7. And I should have probably left a bit more space. And then we're doing A, oops, I'm not going to fit this on, minus root 7. Oh, that's terrible. Okay, and then I'm just going to expand this bracket. So we've got 2x, 2 times negative 5 on 2 just gives you negative 5. And then we've got plus root 7. And then we've got 2x minus 5 minus root 7. So just scrolling back up to the answer, we can't do it any further because we've got a constant and a surd here. So remember, back to surds, we can only add and subtract like surds. So your value of A is 2, B, so it was negative 5, but see in your answer we've got a negative already there, and C is 7. All right, and hopefully I've done that correctly. So I'll just scroll back down so you can see the final answer. So 2x minus 5 plus root 7 times 2x minus 5 minus root 7. And you can check your answer by expanding that if you like. All right, girls, bye.